Hello everyone. In this video, we'll see some more problems related to integration of trigonometric functions. The first one, evaluate integral x square sine inverse of x dx. So first we will consider this given integral as I, and we will use integration by parts to solve this. Integration by parts. So what is integration by parts? It is integral f of x g dash of x dx will be f of x into g of x minus integral f dash of x g of x dx. So that means out of these two functions, that is x square and sine inverse of x, one we have to consider it as integrable function, one we have to consider it as differentiable function. So we will consider let f of x equal to sine inverse of x. Means we are assuming the sine inverse of x as differentiable function, which means our f dash of x will become 1 divided by square root of 1 minus of x square. Now, that g dash of x, that is integrable function, which we will consider this x square. So if I consider g dash of x as x square, then we will get g of x as x cube by 3. So now this I will become f of x into g of x, that is sine inverse of x into this. So I will write it as x cube by 3 times sine inverse of, x cube by 3 times sine f of x g of x, so sine inverse of x, minus integral f dash of x, which is nothing but 1 divided by 1 minus of x square, and then you have this g of x, which is x cube by 3. So I will write x cube divided by 3 times square root of 1 minus of x square. So what we will do now, we will consider the first term as it is, x cube sine inverse of x divided by 3. Here we can take out that 1 by 3 constant outside. Then we will rewrite this x cube as x square into x dx. I mean, x square into x is nothing but x cube. That is why I'm splitting like it. And then divided by square root of 1 minus of x square. Now we will consider, or we will assume, let t square is equal to 1 minus of x square. So if I differentiate both sides, what will happen is 2t dt is equal to minus 2x dx. Or we can divide both sides by 2. So we will get t dt is equal to minus x dx. So the integral, whatever we have, that can be rewritten as x cube sine inverse of x divided by 3 minus 1 by 3 times. See, now we may notice square root of 1 minus x square will become now t. So integral, the denominator will be simply t. Numerator, this x dx, and then there is a minus here outside. There is a minus outside and x dx is there. That can be replaced with positive t dt. So I will put here t dt. And what about x square? We may notice here t square is 1 minus x square, which means x square will be 1 minus t square. So here we will put 1 minus t square. This t and this t gets cancelled. So we can rewrite this as x cube sine inverse of x by 3 plus 1 by 3 times integral 1 minus t square dt. So now we can simply integrate this directly. So our I will become now x cube sine inverse of x divided by 3 plus 1 by 3 times. If I integrate 1 dt, it is nothing but t. And if I differentiate t square, it is t cube by 3. So minus t cube by 3. Then finally, I can include that constant c. Now, what is t? T is square root of this. When you have t square as 1 minus x square, then t will be square root of that, which means our I will become now x cube sine inverse of x by 3 plus 1 by 3 times t. We know t is nothing but square root of 1 minus x square, square root of 1 minus x square minus t to the power of 3, which means it is 1 minus x square to the power of 3 by 2 divided by 3. Finally, you add the constant c. That will be the result of this particular problem. In this question, we need to evaluate definite integral 0 to 1 dx divided by 1 plus x square. This is a straightforward question. So straight away, we can integrate dx divided by 1 plus x square is nothing but tan inverse of x. Let us call this as definite integral, and hence our definite integral will become now tan inverse of x, and the limiting values are 0 and 1. Let us substitute that. So first value will become tan inverse of 1 and then minus tan inverse of 0. Tan inverse of 1 is nothing but 45 degrees. We can write it as pi by 4. Tan inverse of 0 is nothing but 0. So the final result is pi by 4. That is the result for this particular problem. This question, we need to evaluate integral dx divided by 1 plus cot x. Primarily, we'll call this as I. Now this I can be rewritten as integral dx. I can write cot x as cos x divided by sin x. Again, that can be rewritten as LCM for the denominator is sin x. So if I consider sin x here you will get sin x plus cos x dx. That can be further rewritten as integral sin x dx divided by sin x plus cos x. Now, I want a similar denominator in the numerator also. So which means what I will do is I will first multiply and divide by 2, means 1 by 2 times integral 2 times sin x dx divided by sin x plus cos x. Now this 2 times sin x, I can rewrite it as sin x plus sin x. So I want cos x, so I will include cos x. Since additionally I included cos x, I will subtract cos x. The whole thing dx divided by the same denominator, which is sin x plus cos x. Now what we will do is we will combine these two and combine these two. Means I will rewrite this as 1 by 2 times sin x plus cos x and then I will rewrite it as minus of cos x minus sin x, the whole thing times dx divided by sin x plus cos x. Now, individually we will divide in the sense we will rewrite it as 1 by 2 times, let me open a bracket. Individually, if I divide this divided by this is 1. So I can simply write dx minus integral cos x minus sin x dx divided by sin x plus cos x. Close the brackets. Now, the first one, 1 by 2 will be common. First one, if I integrate dx, it is nothing but x. If you look into the denominator, if I differentiate sin x, I get this cos x. If I differentiate cos x, I get this minus sin x. So I can simply write this as minus logarithm of modulus of, because logarithm cannot be evaluated for negative numbers, that's why I'm incorporating a modulus symbol, logarithm of sin x plus cos x, the whole thing plus a constant c. That is the result for this particular problem. In this question, we need to evaluate integral dx divided by 3 sin x plus 4 cos x. So for evaluating this, we will be using some trigonometric identities, which are those sine 2 theta is equal to 2 times tan theta divided by 1 plus tan square theta. That is one trigonometric identity we will be using. And the other one is cos 2 theta is equal to 1 minus of tan square theta divided by 1 plus tan square theta. So wherever sin x and cos x is there, we will replace this expression over there. In which case, let us consider this as I. So I will rewrite this I as integral dx divided by 3 times 2 tan, here it is sin x instead of 2x. So I will have to rewrite it as x by 2, 2 tan x by 2 divided by 1 plus tan square of x by 2. And then plus 4 times of cos theta, means it will become 1 minus of tan square of x by 2 divided by 1 plus tan square of x by 2. Close the brackets. Now, in both of them, we have 1 plus tan square x by 2 as common, and we also know 1 plus tan square x by 2 is nothing but secant square of x by 2. So we will use that, and it is a common denominator in that. So let me rewrite it here. So your I will become now integral dx divided by 6 times tan x by 2 plus 4 times 1 is 4. 4 into minus of tan square x by 2 is minus 4 tan square x by 2. And here in the denominator, both are having same common denominator 1 plus tan square x by 2, which can be written as secant square of x by 2. So this again can be rewritten as secant square of x by 2 dx divided by 6 tan x by 2 plus 4 minus 4 times tan square of x by 2. So that is the expression now. Further, in the denominator, I will first bring this square element first, which has got a negative sign. So I will take negative sign outside the integral. So you will have secant square of x by 2 dx divided by, first I will write 4 tan square x by 2, since already the negative sign is taken outside. Then minus 6 times tan x by 2. Then finally minus 4. Now in this, let t, we will consider it as tan x by 2, which means our dt will be 1 by 2 times secant square x by 2 dt. I'm sorry, dx. 1 by 2 dx. So that means our 2 times dt will become secant square of x by 2 dx. So now this I can be rewritten in terms of t as negative 2 dt divided by 4 t square minus 6t minus 4. Now in all these terms, 2 looks to be common. We can take 2 outside in the denominator. So we can rewrite it as minus 2 integral dt divided by, I'm taking 2 outside in the denominator. So you will have 2t square minus 3t minus 2. This 2 and this 2 gets cancelled. Now we can factorize the denominator now. So I can rewrite this integral as dt divided by 2t square minus 4t plus t minus 2. Means this minus 3t, I am rewriting it as minus 4t plus t. So further, this is simplified as, in the denominator, first 2 terms you may notice 2t is common. So we can take 2t outside. So you will have t minus 2 plus t minus 2. Now in the denominator t minus 2 is common. We can take that outside. So we will have t minus 2 into 2t plus 1. Now let us consider, we will use partial fractions to split this integral, means I will rewrite 1 divided by 2t plus 1 into t minus 2 as a divided by 2t plus 1 plus b divided by t minus 2. So if I take the LCM in the right hand side, it is 2t plus 1 into t minus 2, numerator a times t minus 2 plus b times 2t plus 1. Now in the left hand side and the right hand side, denominator is common, so we can equate the numerators. It means 1 is equal to a times t minus 2 plus b times 2t plus 1. Now if t takes the value 2, then what happens? Then right hand side will be 1, left hand side, this term will become 0, because if you put t as 2, this will become 0. So we can ignore that. Then we will have b times 2 into 2 plus 1, which is nothing but b times 5, means, or 5b you can say, which means our b value is 1 by 5. Now, if t is equal to minus 1 by 2, why I am choosing minus 1 by 2? I want to make this term as 0. So 2 into minus 1 by 2 will give you minus 1 plus 1 becomes 0. So that is the reason. Then in the left hand side, it will be 1 only. Right hand side, a times minus 1 by 2 minus 2. Of course, the second term becomes 0 because minus half into 2 is minus 1 plus 1 is 0, which means I can rewrite this as a times minus 5 by 2, which means our a is minus 2 divided by 5. So now we can write this integral I as, therefore, integral I is equal to, so a divided by 2t plus 1. What is a? Minus 2 by 5 minus 2 by 5, that is a. A divided by 2t plus 1. 2t plus 1 in the denominator. Numerator, you will put dt, that will be your one integral. Second one, b divided by t minus 2. b is 1 by 5, so plus 1 by 5 times, what is that? T minus 2. I think I missed something. Yeah, here I missed this thing. Minus 2 by minus 1, actually it is a negative 1. Still negative sign is still there. So here also it will be negative dt. Here also it will be negative dt. So here I need to incorporate, negative everywhere. So this will become positive and here it will become negative. So that means the result I will be 2 by 5 integral dt by 2t plus 1 minus 1 by 5 integral dt by t minus 2. Now, let us consider this u. Let u equal to 2t plus 1, which means du is 2 times dt. So I can rewrite this integral now as numerator 2 dt, which is nothing but du. Denominator, there is a 5, and we also have 2t plus 1, which is nothing but u. So I will say simply 5u. And this one, 1 by 5. If I integrate dt divided by t minus 2, it is nothing but logarithm of t minus 2. So this becomes further log 1 by 5 times logarithm of u minus 1 by 5 times logarithm of t minus 2. So here we may notice 1 by 5 is common. So we can rewrite it as log u minus logarithm of t minus 2, which is 1 by 5 times logarithm of, it is like log a by log a minus log b, which is nothing but log of a by b. Now let us substitute back all this. First of all, u is nothing but 2t plus 1. So it is logarithm of 2t plus 1 by t minus 2. Here let me put plus c everywhere, plus constant c. Now we need to substitute whatever relevant value of that t. What is t? T we initially assume t as tan x by 2. So it is 2 times tan x by 2 plus 1 divided by tan x by 2 minus 2, the whole thing plus a constant c. That will be the result of this particular problem.